Hello everyone, hope you all are well. In our thermodynamics series, today we will discuss some more terms, intensive and extensive properties. Basically, intensive properties are those properties which depends on nature of substance. Nature of substance means quality of substance. What type of quality of that substance? And independent of mass of substance. Mass means quantity of substance, how much amount we have taken. Got it? The properties which depends on nature of substance and independent of mass of substance is called intensive properties. Similarly, if we talk about extensive properties which depends on mass of a substance, means quantity of a substance, and independent of nature of substance, and it's independent of nature of substance, quality of substance. For remember the definition of this intensive and extensive property, you just remember one thing, either in terms of mass or in terms of nature. If we consider in terms of mass, I means intensive, I means independent of what? Mass. Intensive properties are independent of mass. Obviously, if they are independent on mass, they depends on nature of substance. Definition complete. Now reverse is applied for extensive properties. This is a simple way to learn the definition of intensive and extensive properties. Now come to examples. Extensive properties. For example, density, refractive index, melting point, boiling point, etc. There are many more number terms, properties. Now for extensive properties, you just have to remember 5 properties with a simple trick. You know the meaning of hive, Madhumakhi da chhatta. You just love this 5. Hive, in hive there is single E, but you have to remember double E. Hive. H means heat capacity. I means internal energy. V means volume. E means first E, enthalpy. And last E means entropy. These are only 5 properties which are extensive properties. Rest all the properties you will study, that all are intensive properties. After knowing the examples of intensive and extensive property, now one question must be arise. If mass is an extensive property, as we have already studied, volume is also an extensive property. Extensive property. How could we say density is intensive property? As density is equals to mass upon volume. जब A अपने को लिए extensive property है, volume is extensive, then density also must be extensive property. Now we will discuss with one example. Suppose this is a box which is filled with the water, and the weight of this box is W gram. When we cut this box into 2 halves, 2 parts, obviously its weight will get half. That means its mass gets half. Similarly, the amount of water present in separate boxes will also get half. So volume of this water also gets half. Now on applying this formula, density is equals to mass m by 2. We can write it as m by 2 also. M by 2. We can write it m by 2 divided by v by 2. On solving, m by 2 multiply v. This 2 comes upside. On solving, it will be m by v. Initially, density is equals to mass by volume. On changing, mass and volume, density remains the same. That means density is independent of mass and volume. So, which property is independent of mass? Which property is independent of mass? Intensive property. So, density is intensive property. There is one more factor for intensive and extensive property. I have explained about heat capacity. Remember the examples. It is extensive property or intensive property? It is extensive. But when we put molar or specific word before heat capacity, then it will become intensive property. Means when we talk about specific heat capacity, molar heat capacity, then that property will become intensive property. It will be clear when we study about its definitions, because in heat capacity mass is not specified. So we can change the mass. On changing the mass, value of heat capacity changes. So it is extensive property. Means it depends on mass. But in case of molar heat capacity, the mass gets fixed. Molar heat capacity, 1 mole mass is fixed. So if we change the mass, value of specific or molar heat capacity will not change. So these both are intensive properties. Next part is thermodynamic equilibrium. Thermodynamic equilibrium means when the macroscopic properties like pressure, volume and temperature do not change with time. These macroscopic properties we have already discussed. It does not change with time. Equilibrium means when the properties does not get changed. Properties remain same. So thermodynamic equilibrium, it is of 4 types. First is chemical equilibrium. Second one is mechanical equilibrium. Third one is thermal equilibrium. And last one is composition equilibrium. First is chemical equilibrium. Chemical equilibrium is the composition, amount or concentration, any word you can use, of each substance remains same. Means any substance you have taken the amount of material present in it, that is called chemical equilibrium. Got it? Second one is mechanical equilibrium. Mechanical word related to work. If no work is done during that process, that is called mechanical equilibrium. Either the work is not done by the system or on the system. Means ना system ਦੇ ਉੱਤੇ ਕੋਈ काम ਕੀਤਾ ਗਿਆ, ना system ने कोई काम ਕੀਤਾ है. That is a mechanical equilibrium. Third is thermal equilibrium. Thermal word is related to temperature. Equilibrium means वो चीज same रहेगी. Thermal means temperature remains constant. Last one is composition equilibrium. Composition equilibrium basically means when the chemical potential of each component is same. Chemical potential of each component same for all the 3 phases, solid, liquid and gas. When the chemical potential of each component is same. Now the word chemical potential is new for us. Chemical potential basically is change in Gibbs free energy. Gibbs free energy is represented by G due to addition of Gibbs free energy of a system. Due to addition of 1 mole of substance. When we add 1 mole of substance in the system, then there is a change in Gibbs free energy that is represented by capital G. And this expression represents the change in Gibbs free energy with respect to the composition at constant temperature, pressure. These all things were constant. Our next term is reversible and irreversible processes. Reversible processes are those processes which are carried out at infinite small rate. Infinite small rate means very slow, very much slow. So the reactions which are carried out at very slow rate such that P outside will becomes equals to P inside, means pressure inside the system becomes equals to pressure outside the system. So the speed of this reaction is very so slow and the change will be negligible. We cannot determine the change. Suppose we can understand this reaction with the help of this diagram. This is a piston on which we apply some pressure. Here is the gas. These are gas molecules present inside this vessel. These gas molecules apply pressure on this piston from inside. So this is called P inside. So this pressure is called P inside, and the atmosphere applies. We know that there are the gases present in the atmosphere. That gases will apply pressure from the atmosphere, that is called pressure outside. Got it? What will happen in case of reversible reactions? The reaction is carried out at very slow rate so that this pressure will become equal. P outside becomes equals to P inside. If the pressure will become equal, then this piston will not move, so that no expansion, no compression will take place, means the gas will not expand or not compress if the pressure outside and inside is same. This process is called reversible process. Now we proceed to irreversible process. Irreversible process is that process which is carried out at a very fast rate. If it occurs very fast rate, then we clearly understood that its pressure outside and inside is not same. So here are two cases. One is expansion and another one is compression. What will happen in expansion? In case of expansion, P outside is less than P inside. See in this diagram. P outside is less. In case of expansion, P outside is less and P inside is more. If we apply more pressure from inside, then this piston will move upside. What will happen? This piston will move here. So there will be the expansion of the gas. The gas molecules from here move to here. It leads to expansion when the pressure inside one will more than outside pressure. Second case, compression, when P outside is more than P inside. This is the piston we have already placed. These are gas molecules. This is pressure inside and this is pressure outside. Now, in compression case, what will happen? P outside is more and P inside is less. If P inside is less, then more pressure will be applied from outside. This piston moves downside and the gas will get compressed. So in irreversible case, the irreversible process, there are two cases possible, expansion and compression, on the basis of which pressure is more, external or internal, means outside or inside. For outside pressure we can use P external. For inside pressure we can use P internal. Now along with this, there are some more points of difference between irreversible and reversible process. Here are some more points of reversible and irreversible process. At any stage, equilibrium is not disturbed because the process takes place very slowly. So the equilibrium will not disturb at any stage. But in case of irreversible process, it occurs at very fast rate. So equilibrium will only achieve when the reaction is complete. Because if the steps are very fast, then equilibrium will not achieve. Then it is imaginary process. Any process gets reversed. This is completely an imaginary process. it doesn't take place actually. But irreversible process occurs actually in the nature. Next is work done is maximum in this process. After this, when we start the topics, we will derive the term work for reversible as well as irreversible. The expressions of that completely tells us that work done is maximum in case of reversible process, but work done is not maximum in case of irreversible process, because here the steps are very slow. So that's why work done is maximum in this case. It is completed in infinite time if the steps are very slow. If you are doing any task with very slow speed, then it will take more time to complete. Similarly, if you do that task in very fast speed, you will get a finite time, nearly hour, 2 hours, 3 hours. Reversible process will be complete in infinite time or infinite steps. It takes finite time to complete. This is all about reversible and irreversible process. After this, we will start a main topic of thermodynamics. These are some terms which we have to remember as well as which we have to understand before understand the topics of thermodynamics. That's all for today. For more such videos, kindly like, share and subscribe this channel. Thank you and have a nice day.